In this video, we're going to take a look at section 4.6, which is on special factoring. In this section, we're going to look at factoring polynomials using different various formulas. The first two formulas that we're going to study are these perfect square trinomials. And so we can factor polynomials that fit this particular form. We have a squared plus 2ab plus b squared. So the key here for our problem to fit this formula is the first term has to be a square, right? Has to be something to the second power, and our last term has to be something to the second power. And then we have to check that our middle term also matches up to this 2ab, which is 2 times whatever's getting squared here times whatever's getting squared here. So if all three of those parts match up, then this formula tells us that we can factor this polynomial as a plus b to the second power. We have a very similar formula here. The only difference is we have a minus sign here, and that will factor as a minus b squared. So all we have to do for these problems is check to make sure our problem fits that formula on the left-hand side. If it does, we can factor it as we see on the right-hand side with whatever a and b happen to be for our particular problem. So let's take a look at an example. We have a squared plus 18a plus 81, right? So I'll notice, first of all, that the first term is something to the second power. So here we have a to the second power. So that's the first term. The last term is not written with a power of 2, but I could write it with a power of 2. 81, I can write as 9 to the second power. And so we have the beginnings of being able to match this particular formula, right? We have, I guess I'll write it down here. A squared plus 2ab plus b squared. We have the first term lining up just fine, right? In fact, it's literally the same thing. It's a squared, just like we have in the problem. And the last terms are lining up pretty well, right? Instead of b squared, we have 9 getting squared. But I managed to write both my first and my last term as something to the second power. And that's a really good sign that this formula is going to be applicable. Now, the last thing we have to check is if these are matching up with each other. Does 18a line up with this 2 times a times b? The way we're going to check is to take 2 times whatever is playing the role of a in our problem, which happens to be a again, right? Instead of a squared, we have a squared. So a is playing the role of a, times whatever's playing the role of b in our problem. In this case, instead of b, we have 9. So 9 is playing the role of b, a is playing the role of a. I plug those two things into the middle term of this formula, right? So we have a for a and 9 for b. And then I'm going to multiply this out to make sure it matches up to that middle term, which it does, right? 2 times a times 9. The 2 times the 9 gives me the 18. The a just gets copied down. And so it perfectly matches the middle term that was given to me in my problem. And so if all three of these things are a match, the first term is something squared, the last term is something squared, and the middle term matches up to this 2ab, then the formula tells me I can factor this as a plus b squared. But we have to swap out the a and the b in the formula for what a and b are in our particular problem. So in our problem, instead of a, I know it sounds a little weird for me to say it that way, but it makes sense in most other cases. Instead of a, we have a, right? We're using the same letter in our problem. And instead of b, we have 9. So we make the same changes over here that we see happening between our problem and the formula. We'll put a plus sign between those two because that's what's in the formula, and then that gets squared. And that is exactly precisely how a squared plus 18a plus 81 will factor. You can check your answer here by taking this, and you can't distribute the power of 2, but you can write it out side by side. This is going to be a plus 9 times a plus 9, right? A plus 9 multiplied to itself twice. You FOIL it out. You get a times a, which is a squared, a times 9, which is 9a, 9 times a, which is also 9a, and 9 times 9, which is 81. Combine these two in the middle, you get 18a, and so it matches right back up to the problem that we started with. So this is indeed the correct answer. All right, so the goal here is to fit the problem that we're given into the formula, determine what's playing the role of A and what's playing the role of B, and once you determine that, you swap out the A and the B in the formula with what you're given in the problem, just like we did here, and then that gives us the answer. So we swap out the A and the B in the formula on the right-hand side of the formula to get the answer we're supposed to get, and it comes out factored when we do that. All right, because that's what the formula is doing for us. It's factoring it for us. Now for this problem, the first thing we want to do, and I should have mentioned this first on the last example, is you want to factor out the greatest common factor. That is always your first step. I didn't think to mention it on the last problem because it just wasn't there. But on this one, I can see right away there is a common factor because all of these numbers are even. And I think this is the best we're going to be able to do for this problem. I can factor out a 2. So I'm going to factor out a 2. That leaves me with 25s squared plus 30s plus 9. After I factor out the 2, I notice that my first term and my last term appear to be perfect squares. I can rewrite both of these terms as something to the second power. And what's important here is that I'm able to do this so that it's one thing raised to the second power, so I can see what's playing the role of A and what's playing the role of B. I'm going to start with the last term because that's the easier one to do here. 9, I can rewrite that as 3 to the second power. And then 25s squared, I can rewrite that as 5s to the second power. 5 squared gives me the 25, and s squared gets me the s squared. Right. And so matching this up to my formula of a squared plus 2ab plus b squared, I can see that instead of a, I have 5s, and instead of b, I have 3. So 5s is playing the role of a, 3 is playing the role of b in the problem that I was given. I want to double check that the middle term, 30s, matches up with this 2ab. So I take whatever's playing the role of a, which is 5s, times whatever's playing the role of b, which is 3, times 2. So I'm checking to see if this middle term, when I plug those things in for a and b, will match up with the middle term in my problem, which is 30s. And it does, right? I get 2 times 5, which is 10, times 3, which will be 30, and then the s just gets copied up or over wherever you're writing it. And so I get 30s from that, which matches up to the 30s I was given in my problem. So this formula is a perfect fit. We have something for A, we have something for B, and when I use those things for A and B, the middle terms match up as well. And so the formula tells me this will factor, again, like the last one, as A plus B squared, but instead of A, I have what playing the role of A? I have 5s playing the role of A, and instead of B, I have 3. In this particular problem. So 3 is playing the role of B, so it's going to play the role of B in our answer as well. Take the B out, put 3 in its place. 5s is playing the role of A on the left-hand side of this formula, so it's going to play that role on the right-hand side as well. Take the A out, put 5s in its place, and then that gets squared. And then, as always, just like we've seen in all the previous sections, if you have a common factor, make sure you copy that over to your final answer. So we have a 2 as a common factor that should go in front of that. All right. Let's take a look at the next example. All right, so this one, there is no common factor. Even though there's multiple variables, there's no variable I can factor out. And we have 16 and 40, but then we have 25, so there's no common factors there for the numbers either. So I'm just going to jump right into trying to get this formula to fit this problem. So I will rewrite the first term as a square. So to get the 16, I would need a 4 here, because 4 squared gives me 16. And to get b squared, I'll have to have a b in this parentheses, so that when it gets squared, I'll end up with b squared. So those match up. I'll do the same thing with the last term. To get the 25, I would need a 5 inside of this parentheses. So when it gets squared, I'll get 25. And I'll need p inside the parentheses. So p squared gives me p squared. So this is a pretty good match so far. We have something for a to give me the a squared. We have something for b to give me the b squared. So instead of a, I have 4b. Instead of b, I have 5p. The last thing I want to check is do the middle terms match up? Now in section 4.6, it should always match up because that's what this whole section's about. And they're not really going to try to intentionally mislead you, even though I think that actually wouldn't be a bad idea, because the technically proper thing to do here is you have to check all three terms. Can you write the first term as a square? Can you write the second term as a square? And once you've done that, does the middle term match up to 2ab? That's something that we have to check. Now this one has a minus sign in front of the middle term, so we want to use that particular formula, which tells me this will factor as a minus b squared once I've confirmed that the middle terms do actually match up, which I think you'll find they do. So we're going to take 2 times a, well instead of a I have 4b in my problem, so I'll put 4b here, times b, instead of b I have 5p. Right, and I'm going to multiply that out, and as long as that matches up to the 40bp, we have a match. The formula perfectly fits, and so we can factor it using the formula. And we'll get our answer by adjusting the right-hand side of this formula. So I'll have 2 times 4, which is 8, times 5, which is 40. And then we'll have b and we'll have p to just get copied over. And so it does. It matches up to that middle term just fine. So that means I can use the right-hand side of this formula to factor this problem. I just need to swap out the a and the b with what we're actually working with in this problem. Instead of a, I have 4b. So I'll make the same change over here. Minus, instead of b, I have 5p. And then that's going to get squared. There was no common factor that we factored out, and so this would be my final answer. All right, next we have factoring the difference of 2 squares. So there's only one formula for this situation, and this one's a little bit easier to check because all you need are 2 terms that are both perfect squares being subtracted from one another. And if you have that, it will factor as a plus b times a minus b. So all you have to do is make sure the first term is something squared minus the second term is something squared. And that tells you what is playing the role of a and what is playing the role of b. And once you've identified that, you just plug those things into this formula on the right-hand side to get your answer. Assuming the GCF has already been factored out, a squared plus b squared cannot be factored. So if you're adding the 2 squares, that cannot be factored. It has to be subtraction for it to work. All right, so let's look at some examples. We have c squared minus 64. So there's only 2 terms. There's no middle term for me to check. There's only 2 terms. And the first term is already just something squared. It's c being squared. Minus the second term is 64, which I can write as 8 squared. And so this fits perfectly into my formula of a squared minus b squared. Right? Instead of a, I have c being squared. And instead of b, I have 8 being squared. So I can use my formula that I have memorized to factor this, and it'll factor as a plus b times a minus b. Now, I'm not sure if that's the order I put those in on the last screen. Yeah, okay. But the order here doesn't really matter. I did do plus first and then minus second. But if you had it as a minus b, a plus b, it's the same answer. So either order is fine on that. And so that's how a squared minus b squared factors. But in my problem, instead of a, I have c. And instead of b, I have 8. So we're going to swap those 2 letters out for what I actually have in my problem. And that'll be my first factor, c plus 8. My second factor, instead of a, I have c, minus, instead of b, I have 8 again. And so this will factor as c plus 8 times c minus 8. All right. Okay, these are going to get a little bit more complicated, but it's the same deal. There's 2 terms here. Now, first you should look for a common factor. I almost didn't see this, but there actually is one. Because this actually would factor anyways, even if you didn't factor out the common factor. But to get the right answer, you have to have the common factor factored out. So you want to get the GCF factored out. And if you don't do it at the beginning, you have to catch it at the end. So you might as well take care of it at the beginning. Both of these terms have an S. So we can factor out the S. We'll factor out the lowest power of S, which is to the second power. That's going to leave me with 49 S squared minus 64 G to the fourth power. All right, so we take away 2 powers of S. That's what I'm left with. Now each of these can be written as squares. So I can rewrite 49s squared. I want to write it as one thing raised to the second power. To get the 49, I'm going to need a 7 in here. 7 squared gives me 49. And to get the s squared, I will need an s in the parentheses. S to the second power gets me the s squared. Minus, we'll do the same thing for the second term. To get the 64, we need an 8 here. And to get g to the fourth power, I would need a g squared inside my parentheses. So that way when I square that whole thing, the 8 squared gives me the 64. G to the second power squared, I multiply those two exponents. 2 times 2 gives me 4. All right, so now this matches up pretty well with our formula of a squared minus b squared, except instead of a, I have 7s, and instead of b, I have 8g squared. So I will use my formula to factor this. The formula factors as a plus b times a minus b, but instead of a, I have in my problem 7s, plus instead of b, I have 8g squared. So that's what I will have as my first factor. My second factor, instead of a, I guess let me draw an arrow for that too. Instead of a, I'll have 7s minus, instead of b, I will have 8g squared. All right, and then before I type this answer into Math Excel, don't forget your common factor from the beginning. So we'll have s squared here in front of my answer, and this would be the final answer. So don't forget your greatest common factor in your final answer. All right, let's take a look at another example. Now this one, the formula does not apply to. So the formula we were just learning, a squared minus b squared, only applies to factoring something that has 2 terms, and only if those 2 terms can be written as something to the second power. This problem starts off with 4 terms, so I cannot apply that formula initially to this problem. What I can do with 4 terms that we've learned in previous sections in Chapter 4 is I can factor this using factor by grouping. So I will group the first 2 terms together. I get w to the third power minus wp squared. And then I always start with a plus sign between my 2 groups. And then group the second 2 terms together. That's 9w squared. But the minus sign in front of that term will stay with this term inside the second group. And then, so that minus sign ends up right here. And then we'll have plus 9p squared. We'll factor out the common factor in the first group, which is just a w. I'll be left with w squared minus p squared. And factor out the common factor in the second group, and that'll be a 9. But I want to factor out a negative with the 9 because I want to change the sign of both of these. I need this to match up to this. This is positive first and then negative. That's what I need to see here as well. So to switch the signs of these 2 terms, I factor out a negative with the 9. And that's going to leave me with positive w squared minus p squared. All right. Then, we're not done factoring. We haven't done any factoring yet because we still have 2 terms here. But because these 2 parentheses are the same, I can factor that out as a common factor. And so I'll write it one time out in front. I'll have w squared minus p squared, one time out in front. And then in a new set of parentheses, I'll have what's left over, which is w minus 9. When I take those 2 parentheses away from those 2 terms, I get w minus 9 left over. And so we factored it, right? We did factor by grouping. We were able to factor this. But if this is what you type into Math Excel or My Math Lab or whatever homework system you happen to be using for your class, it won't count it as correct because this can be factored further. So it doesn't say in the directions, it just says factor. But what's implicit in that is that you factor it as much as possible. You have to be persistent and factor it down until nothing else can be factored any further. So just because you do one level of factoring doesn't mean you're done with the problem. You have to look at the result you get and ask yourself, is there any more factoring I could do with what I see here? And in fact, for this problem, there is, right? We have w squared minus p squared. Now this fits the formula that we were just using earlier, right? This is a squared minus b squared. It literally is that exact expression, except instead of a, we have w, and instead of b, we have p. So we know how this factors. This factors as a plus b times a minus b. So that's how I'll factor this. But instead of a, I'm going to have w. So I'll have w, and instead of b, I'll have p. So I'm going to have w plus p, w minus p. Whoops, I don't know why I'm putting 9. Sorry about that. Let's undo that. W minus p. And then the w minus 9 copies down. So I do want a 9 there, but I was getting ahead of myself, I guess. So this thing here factors like this. And then the w minus 9 just gets copied down. And that gives me my final answer. So I'll just write it one more time over here. W plus p, I did it again. W plus p, w minus p, and then w minus 9. All right, and so that would be my final answer. All right, and the last formula we have in this section is factoring the sum or difference of two cubes. So again, this formula is going to be a little bit easier than the first one that we had to deal with because there's only two terms in these as well. The difference here is that these will be things that are raised to the third power instead of just to the second power. And then when they factor as something a little more complicated. But at least checking to see if the formula applies is going to be a little bit easier. Actually, executing the formula can get kind of tricky over here on the right-hand side. So if you'll notice, there's two different formulas. One for when you're adding the two cubes together. One for when you're subtracting the two cubes. The answer has the same structure in both cases. The only difference is the positive and the negative signs, the pluses and the minuses. The first factor, I should say, in both cases is a and b. In the first case, you're adding. And the way I remember which one is which is the first sign will match the sign of the original problem. So here we're adding the two cubes. So in our first factor, we'll be adding the a and the b together. Then the second sign will be the opposite of the first one. So if this one's plus, this one's going to be minus. Here, we're subtracting in the original problem. So our first factor will have subtraction. So we'll subtract a minus b. And then the second sign is the opposite of that. So we start with subtraction here, so this one ends up being a plus. And then the last term is always plus. All right, so that's how I remember it. And then you have to remember the first factor is a plus b or a minus b. And the second factor is a squared, ab, and b squared. And then you just remember the signs based on the rule I just talked about. All right, so that's to try to help you memorize those formulas. All right, so let's take a look at some examples, and then we'll be done with this section. So we have v to the third power minus 64. So because that's to the third power, I need to use this formula. A to the third power minus b to the third power. And the answer to this formula, the way this formula factors is, again, we'll have a and b in our first factor. We'll have a squared, ab, and then b squared in our second factor. So you just have to kind of memorize that pattern. To figure out what signs should go in front of these terms, we use the rule we just talked about a moment ago. Because my original problem has subtraction, the first factor will also have subtraction. And then in the second factor, we'll start off with the opposite sign. That's a minus, so this one will be a plus. And then the last term is always a plus for both formulas. So this is the formula for factoring a to the third power minus b to the third power. But instead of a, we have v. Right, so instead of a, we have v. And instead of b, we don't have 64 here. We have to rewrite the 64 as something to the third power. So what number to the third power gives me 64? It is 4. 4 to the third power is 64. And so instead of b, we have 4 to the third power. So instead of b, we have 4. Instead of a, we have v. And so we're going to make the same changes over here on the right-hand side to get our answer. How this will factor is a minus b, but in my problem, instead of a, I have v, minus, instead of b, I have 4. So I get v minus 4. And then for the second factor, we'll have a squared, but instead of a, we have v in the problem that we were given, plus, and so that'll be v squared, plus a, which is v, times b, which is 4 in my problem. Instead of b, we have 4. Right? Plus, instead of b, we'll have 4 squared. Right. Now this second factor is a little bit of a mess, so we can't leave it written like this. We need to simplify it. So we're going to have v minus 4 still. We'll still have v squared. V times 4 is just 4v. Usually we put the number in front of the variable part. So when you multiply these together, the number should go first. So it'll be 4v, and then plus 4 squared, which is 16. And so this will be my final answer. All right, so I guess I stopped drawing arrows here. I apologize for that. Let's go ahead and put those in. So it's just like the previous problems. You're trying to figure out what's playing the role of A, what's playing the role of B, and then make the same substitution on the right-hand side of the formula to get your answer, to get how your problem factors. So basically you're memorizing the answer for one problem. You're memorizing it for a to the third power minus b to the third power. You memorize this is how it factors. And then you make changes according to whatever's different in your problem. So what's different here is instead of a, we have a v. So we make the same change in the answer. Instead of a, we'll have a v. And instead of b, we have a 4 being raised to the third power. So we make the same changes over here. Instead of b, we'll have a 4. All right, let's take a look at another example. We have 27v to the third power plus 64. So again, I want to rewrite both of these as something to the third power. We already talked about 64 in the last problem. 64 is 4 to the third power. For 27v to the third power, to get the 27, I need to have 3 here. 3 raised to the third power gives me the 27. And to get v to the third power, I need a v in the parentheses. V to the third power gives me v to the third power. And so this matches up to our formula, a to the third power minus b to the third power. But instead of a, I have 3v, and instead of b, I have a 4. So then I go to the answer to my formula. The way my formula factors, using a's and b's, it'll factor as a plus b. Again, I keep the same sign that I'm starting with over here. And then the second factor will be a squared. I go to the opposite sign here, so minus ab. And then the last term is always positive b squared. So that's the answer I have memorized for my formula. Now I want to make adjustments to the answer based on what I'm actually dealing with in this problem. So instead of a, we want 3v, because that's what I have in the problem I was given. And instead of b, we want 4. So we make the same substitutions on the right-hand side of the formula. Instead of a, we're going to have 3v, and plus, instead of b, we will have 4. Sorry about that. Let's try that one more time. Instead of b, we'll have 4. All right, same thing over here. Now this gets a little bit tricky. Instead of a, we need to have 3v here, and that whole thing, the 3 and the v, is going to get squared. Minus, in place of this a, we will have 3v, times, use arrows still, times b, which is 4, plus, in place of this b, we will have 4 squared. All right, so then we want to simplify this. I'll just do it above this because I don't think I'll have room over to the right. We're going to have 3v plus 4. So the first factor really comes out just fine. You don't have to make any adjustments to it or simplify it in any way. But this one we do have to simplify. And this power of 2 can be distributed to each of these factors. Because if you're multiplying, you can distribute your exponent. It's only when you're adding and subtracting that you can't distribute your exponent. And so this will be 3 squared, which is 9, times v squared, minus 3 times 4 is going to give me 12 here, and then I'll just copy the v over, plus 4 squared, which is going to be 16. And so that's how this one's going to factor. All right, one more example, and then we'll be done. So it's really the same kind of problem, except that right away I see, okay, we have s to the third power. So my immediate thought is I want to have this as something to the third power here and something to the third power here. And I think maybe 192 works with that. I don't know. That's a number I'm not too familiar with. But I know 3 does not work here. If you put 1 to the third power, that's equal to 1, not equal to 3. If you put 3 here, 3 to the third power is 27. So 3 doesn't actually lend itself to this formula very well. There's no number to the third power that's going to give me 3. No nice number anyways. So then that helps me realize, well, maybe there's a common factor here that gets the 3 out of the picture. Because while that 3 is there, it's not going to fit into this formula. So let's try to factor out a 3 first. So if I divide a 3 into the 192, 3 goes into 18 6 times. There will be a 1 as a remainder. We drop the 2 down, so we get 12. 3 goes into 12 4 times. So we're going to get 64, which is a nice number to have because we've already seen it twice. We can rewrite 64 as 4 to the third power. We'll still have s to the third power here, plus when I factor a 3 out of this last term, I'll get a 1. And 1's always a nice number for these formulas because 1 can always be rewritten as 1 to whatever power we need it to be. So 1, I can write that as 1 to the third power because 1 to the third power is 1. And for 64, we can write that as 4. 4 to the third power is 64, and then s. S to the third power gives me that s to the third power. And so now it fits our formula. A to the third power plus b to the third power. Instead of a, we have 4s, and instead of b, we have 1. So we go to the right-hand side of our formula, which will be a plus b times a squared minus ab plus b squared, and we make all the same changes. Instead of a, we are going to have 4s, and instead of b, we're going to have 1. So the first factor will be 4s plus 1. The second factor we're going to have, I don't know what else. I was trying to do 2 things at once there, I think. Parentheses, we're going to have 4s squared, right? Instead of a, we have 4s, but then that has to get squared. Minus, instead of a here, we're going to have 4s. Instead of b, we're going to have 1. So it'll be 4s times 1. Plus, instead of this b here, we're going to have 1 squared. All right. And then we're going to simplify that second factor, get rid of all the parentheses and exponents that need to be resolved. So this is going to give me 4 squared, which is 16, and then s squared. So it'll be 16s squared, minus 4s, because 4s times 1 is still just going to be 4s, and then 1 squared, which gives me 1. All right. And then, don't forget, I almost forgot it. I was about to put a box around that, but don't forget our common factor of 3 that needs to be put in front of this answer. So my final answer is this. Sorry, it's kind of messy, but that's supposed to be a plus sign right there. All right, so we have 3 times 4s plus 1 times 16s squared minus 4s plus 1. I really feel like I want to fix this. I'm sorry. You're probably ready for this video to be over, but I just couldn't leave it like that. All right, so let's try this again. We have 4s plus 1. All right. So that concludes section 4.6, which is on special factoring, which is just another way of saying factoring using formulas.